Hello, welcome to ACI Controls. We are currently in a sanitary welding and fabrication shop, and in today's video I will be chronicling the fabrication of a 10 gallon per minute hold loop for our next pasteurizer. This is usually a 2 to 3 day operation depending on the size, and since this is a pretty small unit, it's closer to the 2 days. The first step is here at the orbital saw, where pipes are precisely cut both in length and in angle. Any deviation in length or on a cut squareness will be a problem when assembling. I will be just showing the steps so as to keep this video brief. I will cover each step in sequence though. If you find videos like this helpful, informative, or at least entertaining, please give a thumbs up, subscribe, and if you are interested in pasteurizers or sanitary fabrication, check the links below for company info. So off to this orbital saw to get started. Now that the pipes are cut, the next step is a rather mundane but important one, and that is to deburr the pipes, especially the inside. I do this by hand to avoid removing more material from the pipe other than the burrs. It's important to make sure you don't have any ridges, etc. from the burrs that could lead to material getting trapped and then bacteria growing in there. So let's get them cleaned out of there. So when you're done, you should be able to run your finger around in there and not feel nothing that could cut or nothing like that. And same with the outside. The outside's not as quite as important, but good to get it done nonetheless. So the next step's going to be, after all these are done, to go to the welder. So now that the pipes are prepared, the next stage is come over here to the welding lathe. I prefer to build my own tooling and fixturing, and that's this lathe was I designed and built this to weld these pipes, but it also gets used a lot for doing the assemblies of the pasteurizers. And it's got its own rotary ground set up back here. And so they start to clamp the assemblies together, and then it has to be backfed with argon. If you don't protect the inside of the pipe, you get covered by precipitation, and the chromium goes out of solution with the iron and forms the carbon, and you have no protection on the iron. So I end up sliding I got an injector I made, goes down inside the pipe, so I'm only purging the very end of the pipe to cut down wasting argon. So purge mine in here. So we set the purge up on here, and I usually try to run this the back purge a little bit lower pressure than the gas flow on a torch. Keep the puddle from blowing up out inside the pipe. And at this point, then I can begin to tack the elbows together before fully welding them. So I use this Lincoln 230 aspect welder. It's an inverter based. I've always used transformers and based ones in the past, and this is my first inverter. The doing stainless welding inverter versus transformer is not that really a big of a deal. It's not until you get into the aluminum and magnesium and the inverter tends to be a much bigger issue. And anybody's interested, I'm going to be doing some videos on the setup and review of this in the future, but for now we're just going to weld some pipes. This welder is capable of doing pulse welding, but I stick to just straight DC. I do use pulse on the orbital, but I don't on this since it's kind of annoying to run. I really don't seem to have that much of a benefit. So the pipe's all configured, set up. We got back purge flowing, got it clamped in, so we'll put a couple tacks in there and then we'll do a full weld on it. So at the moment I just have a variable voltage supply on this and the control rotational speed for different welds and different pipe thicknesses, etc. I do have a prototype over here of a microcontroller based control that uses a class D amp for direction and PWM out of the microcontroller to control speed, and a little keypad and LCD to select programs. I just haven't gotten around to putting the thing in place, so I just use a variable voltage supply for now with a voltmeter to set the speed. I like to hold the gas on there for a little bit after it's done welding, make sure that it's protected. I do have this trailing shield that goes up on here to hold the gas in place. Obviously slides down there to fit, but it's more of a titanium thing than a stainless thing. So plus you can't see the weld with that. So this is I got a few minutes to finish welding the rest of these pipes, and then the next stage is to weld the other end on. and they get welded obviously all set. So it's a flow, get it down through the pipes, and I'll finish welding those pipes, and then I'll go through the other end on it. So here we have the completed welds. That's the earlier weld, and this is the one that was just done. The lathe definitely gives the ability to put a nice smooth weld on there, and not to worry about the shakiness. The pipes are all welded up, all the ends are put on there, and the welds have all been cleaned and take brush and polished up a little bit. So after that, everything gets put in this assembly, and there's a little bit of time involved with trying to get it all lined up. All the angles have to be set properly in here, and this is where it's critical that everything was welded square, the pipes were cut to the right dimension, everything was squared up. And I go through and I tape all the joints that I'm not welding on to seal the gas in there and keep the oxygen out. And it's all set now with the purge assembly. It takes a few minutes for it to purge out. I don't put the end fittings on the whole loop until it goes into the machine and secured to the machine. Then I'll put them in there so they make sure they come out of there perfectly straight. Otherwise, that can be a problem to try to fit in. So the next step is start on this bottom weld, tack it, and orbital, and work my way around until it's all done. So if you don't weld everything correctly into here, get straight pipes. Trying to get these two matched together is a real bear, but as you see in this case, it's coming together real nice with the cup. So the next step is get things out of the way. Since I can't see inside the orbital head to line the tungsten up, got to put a quick mark here. Then we come over to the orbital welder. Click a few buttons and we'll be off to the races. Has to do some pre-purge of the gas, and that lights off. And you can see it uses a pulse weld current instead of a straight DC run. And once it gets back to where it started, it'll start phasing out the current, back it off, stop, and then continue to post-flow gas for a little bit. And then step on reposition and ready for the next weld. So when you're said and done, that's what the orbital gives you. The nice, real nice smooth weld, burns down inside good. And you give it a quick hit with a wire brush, and then just rinse and repeat for the rest of the pipes. So the whole loop is now solidly welded up. All the ends have been done. They've all been orbital. This will stay in this fixture until I'm ready to drop it into the frame. And once it's in the frame, it gets anchored in place. All the angles and pitches get set, and then I will weld on fitting there and weld on a fitting there. And get them lined up good, and then that ties into the rest of the machine. So the next step after this is to start building the frame and continue the process.